we go, people. So if we have 3 ln of 5x equals 10, we are solving for x. So this is similar to one that we just did. Now, think about what are we doing here? The goal is to get the x by itself. So what makes the most sense? Isolate everything that's been done to the x. So let's divide by 3, divide by 3, and when we divide by 3, we get a fraction over here, but that's okay. ln of 5x equals 10/3, right? So we get that. What does ln mean? It's log base e. So log base e of 5x equals 10 to the third. Let's rewrite this as an exponent. So e to the 10/3 power equals 5x. And then from here, if we want to solve for x, what do we need to do to both sides? Divide by 5. There we go. X equals e to the 10/3 over 5. That is the exact answer. Okay. Next, another one where we are solving for x. So if we're solving for x and x is in the spot of an exponent, at some point we're going to need the ln. Now, the first thing I see here, guys, is that let's put 7 over 1, and then let's eliminate the fractions by cross multiplying. So 7 times e to the 6x minus 14 equals 119. Now, I'm looking at this problem and I'm like, you know, I bet that 119 is divisible by 7. What do y'all think? I think it is. 119 divided by 7, check it out. It's 17. So instead of distributing that 7, divide both sides by that 7. Just to make the numbers smaller. So now we've got e to the 6x minus 14 equals 17. If our objective is to isolate the e term, let's add 14 to both sides. And we get e to the 6x equals 31. All right, what can we do from here, Reed, to rescue the x? Yep. ln both sides. ln of e is 1. Fly that exponent to the front. So 6x equals ln 31. Next step, divide by 6, divide by 6. X equals ln 31 over 6. Now think about it. That is the exact answer. These are the types of questions that are going to be on the non-calculator part. Okay? Yes, ma'am. Gotcha. You got it? Okay. All right. Solve. Log 5x plus log of x minus 1 equals 2. So we are going to condense this sum, so it's going to go back to being a product. So log of 5x times x minus 1 equals 2. Remember, if we do not see a base on the logarithm, it's understood to be base 10. So 10 to the second power equals all of that. And this becomes a quadratic equation that needs to be solved. So 100 equals 5x squared minus 5x. 0 equals 5x squared minus 5x minus 100. What should we divide everything by, guys? 5. Divide by 5, divide by 5. Make all those numbers smaller by taking out that GCF. 0 equals x squared minus x minus 20. What are factors of negative 20 that add up to negative 1, people? Factors, there you go. -5 and a +4. Good job. So that's giving us answers of 5 and -4. Now, check for extraneous solutions. The 5 is going to work because 5 times 5 is 25 and 5 minus 1 is 4. 5 times -4 is -20. Is there any power of 10 that's ever going to equal a negative number? No. So the -4 is extraneous. Only the 5 is a real solution. Okay. What interest rate would be required to double your investment in 12 years if the interest is compounded monthly? So, what are we going after here? We're after R. Now, this is similar to one that we did in class. Am I giving you a principle? Did I give a principle? All right, if I didn't give one, does it matter? No. All right, so Zoe, give me a number. 1. Easy enough. Let P be 1, and if we double it, then that means A would be 2. It doesn't matter what you start with for your principle, you just need to double it. All right, what else are we given here? We're given that T is 12, and we're given that N is what? Also 12, exactly. So 12 years, compounding monthly. You have to know that compound interest formula. It is A equals P times 1 plus R over N to the NT. We are after R. So here goes. A equals 2, P equals 1, 1 plus R over 12 to the 144th power. Does that make sense, guys? Okay. Now, if we divide by 1, does it change anything? Nope. Okay. So, do we need a logarithm here? No, we do not. So, let's think about this. If we don't need a logarithm, how are we going to undo the 144th power? What would undo a second power? Not square, not the 12th root, bigger, the 144th root. So we are going to take the 144th root. So what is the 100? It's going to be a super tiny number, right? But what are we after here? We're after a rate, which is a percentage, which will be a decimal. So does that sort of make sense? Yes. Let's check it out. So 2 to the 1 over 144th power. So what do we get? We get 1.00485. Don't be hasty in making a quick round there, okay? Go way out there. And also, just let it hang out in your calculator because we're going to need it there. So what is that equal to? The 144th root is going to cancel the 144th power. Y'all agree? Okay. So what do we have here? We've got 1.004825 equals 1 plus R over 12. All right. So what is the next step down here, guys? Yep, take the 1 from both sides. So that just cancels the 1. So now we've got 0.004825 equals R over 12. What's the next step? Multiply by 12. Multiply by 12. Times 12 times 12. That's going to give us our rate. So let's see. I'm going to keep my number, which I've still got right there, minus 1, and then times 12. So we've got a rate, an R value of 5.8%. 5.8% to double our money. Look at the whole problem again. 5.8% is our rate that's required to double our investment in 12 years if the interest is compounded monthly. Does that make sense? Yes, it does.
Would you rather write it 0
Well, it's a rate, and an interest rate should be in the form of a percent. Okay? Let's graph. Y'all want some graph paper? It's right up here. So if we have y equals 3 to the x plus 2. How about let's first graph y equals 3 to the x, the parent function. Let's graph y equals 3 to the x. If we're going to graph y equals 3 to the x, let's make a quick xy chart. Before we do anything, what's the domain? What's the domain of an exponential function? Any exclusions? Think about this. Is there anything that I can not raise 3 to? Can I raise 3 to negative numbers? Yes. Can I raise 3 to 0? Yes. Can I raise 3 to positive numbers? Yes. What's the domain? All real numbers. We can put in anything we want. So let's put in -2, -1, 0, 1, and 2. Those will all fit on our graph. So if y equals 3 to the x, 3 to the -2 is 1/9. 3 to the -1 is 1/3. 3 to the 0 is 1. 3 to the first is 3. 3 squared is 9. And we can easily plot those points. So I'm going to put my parent graph over here so we can see it very nicely. There we go. Whoop. 1, over 2 up 9. So here is our parent graph. Now, what, guys, is that plus 2 going to do to the whole graph? Where's it going to move it? Up 2. The entire graph is going to move up 2. I'll do that in purple. So basically, every single one of these points is just going to move up 2. That's it. So up 2, up 2, up 2, up 2, up 2. Which now, instead of the horizontal asymptote being 0, where's the horizontal asymptote? The horizontal asymptote is at y equals 2. I'll put that in yellow right here. So we've got a horizontal asymptote at y equals 2. Does that make sense? Okay. Now, the one thing I did not put, let's go back here and let's finish off that domain. Okay, so what I gave was the domain for the parent function. Is the domain anything different for the real answer? Okay. So we've got a horizontal asymptote at y equals 2. The domain is still all real numbers, but the range of the y equals 3 to the x plus 2 is lifted up, so the range is 2 and bigger. Okay? So I have no problems with you penciling in that parent graph and then making the transformation. All right. Graph log base 3 of x plus 1 minus 2. Let's start, guys, with simply, I forgot the y on there, y equals. Let's start with log base 3 of x, and then we'll make the transformation. Log base 3 of x. Let's start there. So let's make a little table of values. Now, do we have domain restrictions this time? Yes, because powers of 3, are they ever going to be negative? Are they ever going to be 0? No. Okay, they're not. So let's think. The only thing I should really plug in here are powers of 3. So let's start with 1/9, 1/3, 1, 3, and 9. Those are just the simplest powers of 3. So if x is 1/9, y is -2. If x is 1/3, y is -1. If x is 1, y is 0. If x is 3, y is 1 and 2. Excuse me. This gives us our parent function. All right, so let's plot the parent function. So over 1/9 down 2, over 1/3 down 1, 1, 0, 3, 1, and 9, 2. So this is our parent function. Now, where are every single one of those points moving? Do you know? Well, what's that +1 right there going to move them? 1 to the left. And where's the -2 going to move them? Down 2. So we're going to go 1 to the left, down 2. Every single point is going 1 to the left, down 2. 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 Here's our graph. And we don't have a vertical asymptote, or excuse me, we don't have a horizontal asymptote, we got a vertical one right here. So let's write in our domain and our range for our graph. So the domain here, think about it. If x plus 1 is in the parentheses, then x plus 1 must be strictly greater than 0. So x must be greater than -1. So our domain is -1 and bigger. Our range is all real numbers. And we have a vertical asymptote at x equals -1. Remember, the domain and the vertical asymptotes, they're BFF. They go together. Okay. We're done. Look at there.